In episode 7 of Mobycast, we continue with part 2 of a technical series around the creation of containers. Specifically, Jon and Chris get super deep into Docker networking. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
All right, so getting into today, last week, as we were talking about Docker containers and setting them up, the two things that we talked about were making your life easier by punching a hole into the container file system through something called volume mounts, and that those are a little dangerous outside of development. So you want to have volume mounts when you're developing, and you definitely don't want to have them when you're deploying to, at least not for the purposes of hot updates. There may be other reasons you want volume mounts for staging or production, but not for the purposes of doing hot updates of your development code. And then the other thing we talked about was, what's the right balance for your base image? What things should be included in it? Should you build your own base image and store it somewhere? Can you base a base image on something else, kind of like a GitHub fork? And we talked about all that. And I think we came to a pretty good place when it comes to how you set up an individual container. But a lot of applications, in fact, almost any sophisticated system will involve more than one application, and those applications need to talk to each other. And recently, everybody loves calling that microservices, especially if each application only has a small little thing that it's responsible for doing. And there are some things about having containers talk to each other that are worth exploring. So that's what we'll talk about today. How do you get containers to talk to each other? And what kinds of setups are, good best practices for doing that? So I think the three things we'll talk about today are container networking, dealing with timeouts when you have sort of a chain of microservices talking to each other, and then just dealing with authentication across different containers. So let's start with networking. And in order to talk about networking across multiple containers, I think we first need to just talk a little bit about how networking works for a single container. We've never talked about that from a technical perspective, so maybe we can just dive right in with that. Chris, do you think you can give us an explanation of how container networking works?
Yeah, let's see if we can keep it kind of simple, because it's definitely a big topic to talk about it in a comprehensive way. But with the single container, I guess we can think of networking as, at the end of the day, being pretty straightforward and simple, where it's it needs to make connections outbound to known things, and it's reaching out probably via DNS names. And likewise, it's able to receive requests as well that are forwarded into it. So all this is proxied through the Docker networking services, since the container, like we've talked about before, how the container has a virtual environment of all the various the hardware abstractions and whatnot. So,
Chris, to stop you there, I think that I just want to summarize what you said so far by saying, the container is like any other computer in the network. It can talk outbound, it can receive inbound communications, but even though it's like an independent machine, it depends on its host operating system to be able to achieve that. And that's where things get a little tricky. And that's what I think you're about to talk about.
Yeah, from the single container standpoint, I guess just the important thing there is just knowing that, it acts like anything else that you would have. You really don't have to do anything special, other than you may need to do some setup to kind of tell Docker itself, what connections it's listening to on the inside of the container versus the out. So it's port mapping. So you might say, if let's say you wanted to set up a web server and it's being hosted inside of a Docker container, and so on your you want to launch your browser on your host computer to go access that, and you may want to access that at port 80, or maybe it's port 8080. But inside the container, maybe the code itself is designed to listen on port 80. So you can set up that mapping. And so the networking for inbound is definitely just there's some setup there, because you're doing that translation, versus the outbound stuff just usually works out of the box because Docker is just handling that proxying for you. So with a single container, it's pretty straightforward.
I guess I'm still a little confused. So if a container is like any computer in any network, then, and say that web server is running on that container, I don't really understand why I would need to map ports. Like, couldn't I just say, here's the IP address of the container. I want to hit it at port 80. And I'm anywhere. I could be on the host operating system, or I could be on some other computer somewhere else. And can't I just talk to that container as though it's just out there available as any old computer on the network?
So where the difference is that containers themselves are, again, supposed to be like this isolated thing that they can't see anything else in the world, but they really are running on the same. At the end of the day, they run on the same machine. So if you had a bunch of containers that were all just independent applications, and they all were set up to say, "Hey, I'm going to listen on port 80." If that ended up being the actual port that they were listening to on the host itself, then there would be collisions, right? It's not going to work. So you just said the thing that helped me understand. Do containers not have their own independent IP address? They do inside their container and on the Docker network.
Okay. So they'll have like a private IP address, like a 10 dot something?
Correct. So there are networks that are being spun up by Docker, and so they have their own internal networking inside their container space, which is what they have to, right? Like it's to them, to the containers themselves, they look like they're a computer on a network, right? So they do have an IP address. That is a different IP address than the actual host IP address, right?
Let me ask another question then. I'm just trying to get my head around this. So a container cannot be on the same subnet as its host machine?
No, it will not be, right? So again, the Docker itself is instantiating its own internal networks for these containers to run on.
Right. So a host machine may also be on an internal network, and it might be on like a 192.168.1, maybe its IP address is 5. And then the container, say there's 3 of them on the host machine. Each one of those might be like 10.0.0.1, 10.0.0.2, 10.0.0.3. The host machine is almost acts like I guess it would almost act like what's the word for that when a machine has 2 IP addresses, one to talk to an internal network and one to talk to the outside network, a gateway. So the host machine is almost like a gateway to the Docker network, right? It's got an ability to talk to the Docker network containers, and it's got the ability to talk to whatever network it's also sitting on, right?
Right, and that is that gateway is basically Docker itself, the Docker daemon that's providing that gateway, that proxy, if you will.
Okay, cool. All right, I'm getting my head around this. Makes sense. Rich, that was just a little bit of a kind of a deep dive on some networking stuff. I don't know. Working in your area, I know you do a lot of DNS work, but I'm not sure that you've had to do too much with subnets and things like that. Do you have any questions already, or were you able to follow any of that?
I'm able to follow it, but not much more than that. I think.
Okay.
I think I'm a little bit underwater, but I can't even ask you a question right now.
No, that's okay. I think for those people listening, we can't really dive all the way in and explain how networking works from the ground up, but I think that the thing that comes out of this is you probably will be a little confused and a little underwater with Docker and using it if you don't have a fairly solid base understanding of how subnets work and how IP in general works. So, that would be your take-home homework, is to go read a little bit about that. Okay, so Chris, now you had said we need to do port mapping, and that's where I kind of lost you. I was like, why do we need to do port mapping? Because can't I just can't I just send messages directly to these Docker containers? And you were like, yes, you can. But since now I understand, since they're hidden in their own subnet, I can't really address them. If I'm not in that subnet, I can't. So a thing for you, Rich, is that machines in one subnet cannot, if it's a private subnet, they cannot talk to machines inside another private subnet. So if my IP address is like 192.168.1.5, I cannot see a machine whose IP address is 10.0.0.5. I just can't see it. It's not available to me. I can't send a message to it. I can send a message to another machine in my own subnet, and then that machine can forward that message inside of its, if it has access to that private subnet, it can forward that message along to the machines in that private subnet. And you might need to do some port mapping because it might just spray that. Actually, now I'm a little confused again. A message it might end up having to go to any and all of the containers inside that subnet. Is that right?
So I think there's two kind of distinct topics here. One is the port mapping that we talked about, and the other one is basically subnets and routing, right? So like when we talk about like public versus private subnet, it's usually like in the context of cloud networking, and usually we basically public subnets are subnets that are reachable via the internet. So they do have like an internet gateway, or they have a route in the routing table that allows them to receive traffic from the outside internet as well as to send traffic out to the outside internet. So that would be a public. So it's really just there's a route there that allows it for that transmission to happen.
Good point. And I just wanted to jump in and say that the mistake I was making in the public-private subnet terminology that I was using is that I was kind of saying private subnet to mean a network of computers that have private IP addresses. But Chris is much more correct in saying that pretty much all subnets have private IP addresses, but it's just a matter of whether those subnets are reachable from the outside world with a gateway that has a public IP address.
Yeah, private subnets are basically just they're subnets that there's not a route in the routing table that allows them to directly connect to the internet. Instead, usually they'll have you'll have a NAT gateway, a route to a NAT gateway, which is a network address translation server that does the proxying on behalf of that, so that this allows your those machines on the private subnet to talk to the internet, but not directly. They're going through a proxy, so it's a kind of definitely a security mechanism. So that's kind of like so Docker itself, when you're instantiating your containers, it's creating its own subnets, if you will. It has actually DNS built into it as well. It's doing it has routing tables that it's setting up accordingly so that like this stuff happens, right? And that's part of that whole Docker networking services. So the analogy of private and public subnets definitely carries over into the whole Docker networking ecosystem. So I guess the important thing there is that in order for anything to talk to anything, there needs to be a route to it in a routing table somewhere. Port mapping, where that comes into play is, again, if it's all a matter of just if you have multiple apps running inside containers that are all kind of doing this standard way of listening to things. So like, again, a web server, most web servers, they're going to listen to port 80 for regular HTTP traffic and port 443 for TLS encrypted traffic. But if you wanted to run like 4 different web servers on your machine, you have to do something has to give, right? You can't hit all of them on port 80 outside the container because there would be these collisions. So port mapping just comes into place when it's just out of necessity where you have to change that.
That's the piece though that I was stumbling over. You said there would be these collisions, and it's because outside that subnet or that little network of containers, you can't see them individually. So you can't say this request is for container A and this request is for container B, because you can't see their individual IP addresses. You cannot address a message to them individually, right? That's what I'm trying to get my head around. They're all hidden. They're all on their they cannot be seen individually or addressed individually from outside of the network that they're in. Correct?
Kind of, but it's definitely a bit more nuanced than that. So this is where like ports really do come into play. So like if you are just running all this stuff locally on your own machine, you spin up a container, and it's a web server. You now want to hit it from your browser. You're launching Chrome on your your host machine, right?
Mm-hmm.
So what address do you go to, right? So one of the like with kind of the latest versions of Docker, you could just go to localhost, right?
Mm-hmm.
The loopback address that's what Docker is set up to kind of like to bind to. So you can just say, hey, go hit localhost. And if you don't give it a port, right, it's gonna, your web browser is gonna assume port 80. So if you launched a container and didn't do anything with port mapping, and inside you're basically just saying, hey, I'm going to use the defaults and I'm going to just let this listen, at port 80, then that's all going to work for you, right? You don't have to do anything. It just, Docker knows, like it just says, hey, I've got these containers. Here's the ports they're bound to, so that when I get these outside requests, that I'm going to route them accordingly. So that's where this, like the port mapping really comes into play, because if you now have another container that you want to spin up, web server B, you just need to expose a different port for it. And then that way, when you request it from your browser, you tell on the basically in the browser, you're saying, I don't want to go to just a localhost. I want to go to localhost : whatever port it's listening to. And that's the information that then allows Docker to say, oh, like I'm going to route this request to that thing.
So I think I finally had my aha moment, because here I was thinking that the containers had their own IP addresses, and you just said you would go to localhost, but that's the IP address of the host machine. So why am I not going to like some other IP address like 10.10.10.0.0.4 to hit my container?
This is a fun talk today, because this is like super technical, right?
I know, yeah, it is.
We're going like super deep, because there's definitely a lot of layers that are going on here. So you have the networking at your host computer level. It can't see the networking that's, going on inside these container spaces, right? So yeah, there's these private subnet spaces and networks that Docker's creating inside of it, but like your host machine doesn't know anything really about them. You could manually change that and set all that up, but that would be a really big pain, and it's very dynamic and it's changing all the time. So
I thought that the host machine was ending up as kind of like a NAT gateway between the Docker network and its own network, and it sounds like it's not, unless you actually set it up to do that.
Correct. It's basically you're talking to the Docker daemon. The Docker daemon is doing that brokering for you, right?
Okay.
So and again, it's going off things like, okay, what address am I binding to on the host machine, and what port am I binding to, and what protocol am I using?
So this is pretty fundamental, because we had this big conversation a few weeks ago about what's the difference between VMs and containers, and we didn't really get into networking that much, but we said, well, one of the big things about containers is that they depend on their host operating system for everything that they do, for talking to hardware, talking to network, talking to disk, and talking to the CPU itself. And here we're really seeing that, because if access to container, if from a networking point of view, you talk to the containers as though they are the local hosts and the host, as though you're using localhost, you're on the host operating system, you're saying, localhost, do this HTTP request for me. And you're not saying, container IP address, do this HTTP request for me, like that for me. Like that really is a pretty big, dependence on the local host or on the host operating system. It's really saying, yeah, these things are computers. They're their own machine, but their networking is really fully the network of the host in a way, right? Mm-hmm. Like that's sort of the aha I'm having here. It's like, oh my goodness, we're not hitting these things as though they're individual nodes on a network, but rather we're just depending on the network of the host operating system.
Absolutely. Like you were always going through that abstraction layer. So like, I'll come back again to like the Docker daemon itself, the Docker services. They're providing all these different subsystems, the functionality of the subsystem. So whether it be networking or storage, input, output, all that stuff is going through. Docker is providing, the actual Docker service itself is providing that as a proxy to its containers and its host, whether its host is bare metal or a VM itself, right? So when you're outside the container, you're going through that proxy. You're not talking to you're not talking directly to the containers themselves. Although there are, again, we could talk for hours on this, because there are technologies that are happening where you can actually directly connect to containers. They can have their own virtual network adapters that are individually addressable. And so folks like Amazon and AWS, they are doing this for lighting up some really great security features and performance features and whatnot, right? So, but for right now, you can kind of think of it as that there's a virtual network interface that from the host, all the communication goes through, and that's provided by the Docker services itself, and then that connects to the proper container, right? The proper container, right?
And so now I completely understand this collision thing and this need for port mapping, and I think I'm going to explain it in a way that can help Rich out a little bit. So, Rich, if you had a computer and you wanted to run a web server on it, you would run that web server and it would start up and it would be listening on port 80. Now, let's say you want to run another web server. Say the first one you run is Nginx, and the next one you want to run is Microsoft SQL, Microsoft's IIS. If you started up IIS would complain, hey, there's somebody else already on port 80. I can't run on here. This is already taken. I'm not going to even start. And that's called a collision, and it doesn't work. And so you would have to run IIS listening on some other port. It sounds to me like containers have the exact same problem. So if you have two containers and they're both going to run in Nginx, you've got to make sure they're running on different ports because they're using the port of the host operating system.
Yeah, and the only caveat here too is that you only need to worry about that if you want them to be hit from the outside world, from the host. So sometimes you could very well just spin up two containers. They're both listening on port 80, and they may not.
That's so interesting.
It just depends on they may not expose themselves to the outside world. So you can just have one container talk to another one via the Docker networking.
Okay, so now I think we understand this, and so and why you need to have port mapping so that you can avoid these collisions. Is there anything else we need to know in order just about how networking works for a single container in order to be able to start talking about, okay, now we have multiple containers. What are we going to do? And they have to talk to each other. Is there anything else we need to understand, or can we move on to that next phase of this conversation?
I think we've gone deep enough, and we've kind of definitely talked about some pretty hairy topics. And I guess this is a good segue because we've mostly been talking about how do you talk to what are the networking ramifications of needing to talk to containers from outside of them. So to go from the host to the container space. And so that's a good segue into okay, let's focus on the problem of how do you get these containers to talk to each other, because each of them, again, this is the one of the prime, one of the core principles of Docker is that these things are isolated. They're running in their own bubbles, right? So how do you actually get these things to talk to each other?
All right. So it sounds like there may be more than one approach to this. So what are our approaches? What can we do?
Sure. So and to kind of set the framework here is, again, if you just have one container, it doesn't have to, there's no other containers to talk to, and it's pretty simple. You're just making requests to the outside world, and it's via DNS that it finds things, right? It's going to google.com or something like that. So it's doing a DNS lookup to find out what the IP address is, and then go and make that connection. So what happens when you have now, two containers? So a good example might be you have a web server, let's say you have a RESTful API server that has a database associated with it. So it's using Postgres as its storage engine for data, and so it needs to go and make these, as request comes in for doing creates or updates on its data, it wants to store them in Postgres, right? So it needs to make a call to that, and so let's assume that that's running in a separate container. So how do these things talk to each other? How do you know what to, how to refer to them? And there's a couple different techniques there. So one is maybe one of the important things to realize here is that Docker itself has its own built-in DNS system. And it does a lot for you right out of the box. And so one of the common use case scenarios is let's assume we're building a microservice. It's an API implementation, and it has a container for the API server as well as a container for the database. You may go ahead and you're going to use something maybe like Docker Compose to define these two containers in a Docker Compose file. You're going to give these containers names, and then you can use Docker Compose to instantiate these two containers, right? When you do that, Docker Compose does some really nice things for you in that it sets up its internal DNS to create aliases for those containers by those container names. So if I've named my one container API, and the other one is called DB, I can now actually, when I'm running inside the container, there's now DNS entries for it. So I can do a DNS lookup on DB, and that will actually resolve to the IP address assigned to that DB container. Likewise, the same thing for API. So these two containers can now talk to each other by virtue of the fact that Docker DNS system, it added those entries, it made those available, and then it created a network, and it created a subnet, a network for these things, and it put both those containers on that same network, right? So that's kind of the important thing.
That's so interesting. So once you're inside the container and inside this world of containers, the other containers look more like normal networking to you than when you're outside of it and on the host operating system and trying to talk to them. So all of a sudden the world starts to look like what we're used to with just computers on a network again.
Mm-hmm. Yep. And
Cool.
that's exactly what it is. Right. So it ends up being pretty nice and pretty straightforward when you have a single repo that you're working on, and you have a single Docker Compose file. Don't really have to do anything too terribly special. It's just, it's pretty simple. There's the common network for these things to be running on, and the aliases get it set up via Docker's DNS, and you can talk to each other. So that's the kind of like the simple, straightforward case. The more challenging one is what happens when we've really adopted the microservices pattern, and now we have multiple microservices, and each one of those is hosted in its own repo. Each one has its own database, and maybe you have 5 of these things now, or maybe even 10 of these things, and so each one of these may have 2-3 containers that it instantiates inside each one of their Docker Compose files. And now it gets much more interesting and challenging, because if I don't do anything different, if I go and do a Docker Compose up on microservice A and then do a Docker Compose up on microservice B, by default, those will be created on separate networks, and there's really no way for those things to easily talk to each other, right? To discover each other or to actually make network calls to them. So we have to do something. We have to do something different, right? And so there are various techniques to make that work. One of the most kind of like the straightforward things is basically tell Docker Compose to, instead of instantiating a new network when you do a Docker when you're actually starting up your Docker Compose, instead tell it to use an existing one, or to use a specified one, right? And so now you have 2 different Docker Compose files. In those Docker Compose files, you'll tell each one to say, don't create a new network. Instead, go use this network that we're gonna, some specific named network that we're gonna create, right? So what ends up happening is that then these containers get spun up on that common network, and now they can talk to each other. And we can do some further steps inside there to say, here are the DNS names that we want you to create for them inside this. So we can create these aliases for each one of these containers. And now it kind of just becomes, it's no different than DNS, right? It's
Sure.
You're just saying like, okay, microservice A, its name is going to be, let's just say microservice A. And then when microservice B spins up and it needs to talk to microservice A, it just knows it can just refer to that as microservice A, and all that's just going to work, right? And vice versa. And so you can extend that pattern, for as many different services as you want that need to talk to each other. And that works well when you have, a handful, a couple of these separate microservices. But, if you've really adopted the microservices pattern and you have, 5, 10, who knows, maybe even more of these things, then it gets a little complicated running locally, right? Do you really have like 10 different Docker Compose files with 2 to 3 containers each? And before you can even do anything, right? Before you can, let's just say you're just working on microservice A and you added an endpoint, do you really have to do a Docker Compose up on 10 different things and run all these containers, right, just to get it to work? That becomes an issue. And so then you start asking yourself, maybe I need to have a kind of a dedicated environment where the latest versions of these things can run that I can dev against, that I can test against, right? So that's
Sure.
where the cloud now starts coming into play, where kind of makes sense if you've got this full up microservices architecture with many dependencies, then you have to balance that out. Does it make sense to actually instantiate them locally on my machine, or do I just instantiate the one that I'm working on and I hit these dependencies? I just trust that these dependencies are up to date and running in this other well-known location. So
is that what we do at Kelsus? We have a dev environment on AWS and we just plan on that being there for us?
We're not quite there yet because the need is not quite there. So we don't have enough microservices to kind of reach that pain point where we have that problem. Mm-hmm. So we actually are in a re-architecture design phase where this will become much more of an issue. So we've been going through and kind of looking at our the various services that we have. There is a bit of duplication in them, in that they are a bit more independent, but there is that duplication, and that's causing us for our velocity to slow down. So we've been going through and kind of re-architecting to say, okay, what is the common core services that we have here? And let's break that stuff out, put it into independent microservice units, and then build on top of that. So we are going more to this hub and spoke approach there. And that will increase some of the complexity and start forcing some of these issues that we'll have to start changing the way we do things. But for right now, many of our services are kind of pretty much independent.
That's interesting because that gives kind of a timeline of how things work. So we've been at this for about a year now, going from using platforms as a service, monolithic applications, to using Docker and starting to break out some microservices. And we've been going at it for about a year. And just now is when some of this stuff is starting to become relevant. So, companies that are starting to make this journey, this won't be relevant to them right away. So if this sounds sophisticated and difficult, you'll get a lot of opportunity to learn before you have to tackle this stuff.
Indeed. Crawl, walk, run.
Okay. So, one thing that just sticks out to me that's pretty wild is just that, at the risk of dropping down the rabbit hole even further, is just that, the containers might even be running on different machines. And those machines might even be running on different networks or subnets that can't even see each other. But somehow it seems like Docker is able to just overcome that by creating a system of, if the host machines can talk to each other, then it can figure out a way to route to the containers within the host machines. Even if one container way over here on subnet A needs to talk to some other container way over there on subnet B. Is that right?
Yeah. I mean, for the most part, like you are going through the Docker daemon as the proxy that's running on the host, right? So if you're going from if you're on one host and you need to talk to a container running on another host, you're basically going through that other host first, right?
But from the point of view of the container, it's just hitting a DNS name. It doesn't even realize that it's going through another host, right? So you had said microservice A is the DNS name for one container, and microservice B might be the DNS name for another container, and those are created by the Docker. Those are created by the Docker networking system, and as long as host A that has microservice A in it can talk to host B that has microservice B in it, it doesn't really matter anything about the network architecture between host A and host B. Microservice A can talk to microservice B just with a DNS name. That's what I'm sort of gathering.
No, I think that so the slight difference is that all of that networking has to happen on the same host, right? So that Docker network has to be on the same host, right? For those things to be on there, you can't spread that network across multiple hosts because those are two separate Docker daemons now, and they're not aware of each other. Now that said, there are
because that just pops my bubble. That's like, wait a minute, ECS has this cool feature that lets me just add new hosts whenever I start running out of room on my existing hosts. And why can't all those just talk to each other like one big happy family, like all the containers on all of the hosts in my ECS cluster?
Mm-hmm. And by the way we typically do that, like in something like ECS, is you do it via DNS entries talking to load balancers. And then the load balancers are the ones that manage which host have the containers of that service that are currently running, and then they're able to address them.
Okay.
This is there's other technologies and ways of kind of making this more sophisticated and to do separate things. Docker itself has Swarm, which allows you to create a network of a cluster of nodes, and those do have are able to see each other and talk to each other. But that's separate from Docker itself, right? It's something different. Same thing with ECS and Kubernetes. Like I said, Amazon, they're also coming out with like a different way of looking at networking for Docker with network interface, virtual NICs type thing. So this is very much a very evolving topic. It can go very, very deep. It's very complicated, and there's many different layers to this cake.
Okay. But for the purposes of what we just talked about, so just to make sure I get it right, if we have an API that's exposed to the outside world, the outside world is going to make an API call that's really going to hit that load balancer. The load balancer is going to go send it to a particular host. That host might have microservice A container in it. And if microservice A depends on microservice B, then it might use that DNS name, microservice B, to ask microservice B for something. And then that in turn might ask microservice C for something. But that chain of dependency is all going to happen within the host that was chosen initially by that load balancer.
This gets a little bit more complicated just because of the fact, like when you're running inside something like AWS and you're using an orchestrator like ECS, you don't have control over where your containers are being placed, and you have multiple hosts usually. So in that space, you typically aren't using Docker networking and Docker's DNS system for resolution. Instead, you actually are relying on DNS proper, and you're resolving at the host level. And that's again why DNS, like true, just pure DNS and load balancers end up being a way of doing service discovery and address resolution when you're running inside the cloud, when you're running across a cluster of machines.
Okay.
A lot of what we talked about before was basically the assumption that you have a single host, you have a single node, and you can have the multiple networks on that node inside the Docker space. And how do those things talk to each other? So it is really different when you're developing and using Docker locally, like on a MacBook or a desktop computer, versus like what happens now when I'm running in a production environment in the cloud using an orchestrator. I have a cluster of machines. That changes the game significantly.
Got it. So in your configuration for dev, your URL to talk to microservice B might be configured to be the DNS name of microservice B provided by Docker. But in staging and production, when you're on the cloud, the URL for microservice B will be whatever the load balancer's URL is for.
Right. You're using something, like Route 53.
Okay. Got it.
Mm-hmm. Yep.
All right. Did we just do networking to death? Is there anything else we should talk about on networking?
Did we lose Rich?
I am still here physically. I can say pretty confidently that you're explaining it really well. I just think this is one of those episodes that will encourage some of the less experienced listeners to go back and listen to it a few times. I certainly will. Right.
Mm-hmm. So here's the conclusion that's coming to my mind from today's conversation. Remember a while back, we had the conversation of why should you do this? What's the value here? And one of the big things that came out was, well, it's sort of like doing software development the hard way. It forces you to learn certain things that you maybe glossed over or didn't have to really understand to accomplish your job. Well, did you just notice how we couldn't even have a high-level conversation about networking because we just had to get deep? I just couldn't make sense of it without getting out into the weeds and having you really explain to me sort of how networking works and how that's different with Docker. And that just happens over and over again. And so now I'll walk away from today just more knowledgeable about software, computer networking in general. And that, having that happen to the rest of your software development team is just such a great thing.
Absolutely. And wait till we start talking about storage engines and like LLVM versus XFS or something else. So there's a lot going on underneath the covers. And it's one of those things where you do, like, once you start peeling back that onion, like it makes things come together so much better. And it gives you that kind of like that core foundational knowledge that just makes you a better engineer, a better developer.
Right on. Well, thanks everyone for joining.
Thanks, guys.
Yeah, thank you. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/07. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.